Brandon Clayton here, the Algebra Guy. Today, as you see on your screen, we will be discussing converting fractions to decimals using long division. As you see on your screen also, you should be able to answer this question at the end of this. After converting this fraction to a decimal, we can just add these decimals together. But can you do that? If you can, this will be a cinch for you. Reinforce that learning. If not, please follow along. So, how do we convert fractions to decimals, and what is a repeating decimal, and what notation is used to represent a repeating decimal? So we'll answer those questions here today. First, our setup is as follows. In decimals, we learn to convert decimals to fractions. Now we're going to do the reverse by converting fractions to decimals. Remember that the fraction bar indicates, this bar right here indicates division. So 4/5 can be written or spoken as 4 divided by 4, or set up this way, which is the same thing as 4 divided by 4. So this should give you a clue what we're going to be doing, because this is a fraction. However, when I set up like this, you know it's going to give me an actual number, particularly a decimal. This means we can convert a fraction to a decimal by treating it as a division problem. To convert a fraction to a decimal, we're going to divide that numerator by divide the numerator of the fraction by the denominator of that fraction. So here we go. Let's do that now. 3/4. That's kind of one you just go to. You already know, because you can divide $1 into quarters, and 3/4 is 75 cents. So you definitely want to just know these. But let's do it. Start out with something pretty basic. 3 divided by 4. Now resist the temptation of a lot of students wanting to put a 4 in there. Why would a student want to put a 4 in there? Well, because usually the number as a dividend is bigger than the divisor, and it's just more comfortable just to put a 3 there and say this goes into the one time and continue working. However, that's not what this one tells us to do. It says 3 divided by 4. So we're going to divide that 3 into 4s. So what does that look like? All right, so 4 can't go into 3, so I need to put a 0 here. And I know I'm getting now into a decimal. I'm going to have to add a 0 here and say, okay, it can't go into 3, but can it go into 30? Well, 4 goes into 30 7 times. 7 times 28. 7 times 4 is 28. Subtract 2. And we put another 0 here. I'm sorry, I'm writing crooked. Put another 0 there. And 4 goes into 20 5 times. And that's where we're getting our 0.75. Bam. All right, what about this one here? How do we divide this one? Well, first of all, we're going to remember that negative sign. 7 divided by 2 is still going to be negative. So whatever we do, just keep that in mind. So let's go ahead and do that though. 7 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. We need to add a 0 here, and we're going now into a decimal because this is smaller than this whole number. So we bring down that 1. And 2 goes into 10 5 times, showing us that the decimal is going to be 3.5, but not quite, because we got to remember that negative is 3.5. Be a negative 3.5. as our answer. All right, let's do this one. 4/3. 4 divided by 3. Now, I hope you pausing this and working these yourself, because you'll learn a lot faster that way by just kind of messing around, getting them right, getting them wrong, but your brain is learning. All right, so 4 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. I'm going to put a decimal here, and I'll make a 0. So bring this 0 down. So 3 goes into 10 3 times. 3 times 3 is 9. That leaves 1. We can bring a 0 here. Bring that 0 down. 3 goes into 10 3 times. 3 times 3 is 9. 1. Bring a 0 here. Bring a 0 down. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. bring a 0 here and 0. Okay, I know I'm being redundant, but I did that on purpose because this whole point was to show that what repeating decimals are. And I think you saw what happens. No matter how many times we make a 0, we continue to get 3 and 3 and 3. And if I did this 17 times, what do you think it's going to be? Yep, 3. So your answer here is 1.3333333, and you can't actually stop because it goes on forever. But how could we show that this number repeats forever and ever? So we could write that simply 1.33 and put a line over top, and that communicates to the person looking at this number that this is a repeating decimal and that particular number repeats. 33 is going to keep repeating. Repeating decimal is a decimal in which the last digit or group of digits repeats endlessly. So it doesn't have to be the same digit, matter of fact. It could have been 1.217171717, and you could have rewritten this 1.217 and put a line over the 17. Since it's the 17, that's the repeating part. So the part that keeps repeating is the part that gets the line over it that communicates this part keeps repeating. All right, let's try this one. 43 divided by 22. I almost wanted to go in there twice because it's so close if it had just one more number higher, but it can only go to once. And it's going to be 21. 21. And I want a decimal. Bring this down. 22 goes into 210. I'm going to guess 9 times. 198. Yep, 9 times, so that's 198. Leaving us 12 after we subtract. And making the 0 here, bringing the 0 down, we got 120. I wonder how many times we're going to go into 120. So 22 times, let's see, probably, let's do 8 and see how close that gets us. 6, 1, 16, 176. Oh, that's way too big. 5, yeah, maybe 5, 10, 11. Can we put another 22? Nope, it's going to be a 5. So 22 goes to 125 times. 5 times 22 is 110. That leaves me with 10. 0, 10. And we got a 0. Whoa. Bring down a 0. We end up with 100. 22 goes into 100 how many times? So it's going to be less than 5. 22 times 4. It's going to be 88. Goes in there 88 times. So that's 4. This is 88. We're left with 12. So that brings it back to this 120 again. Interesting. So that's going to go in there 5 times. 5 times 22 is 110. I think I'm starting to see a pattern. Uh-oh, we got 100 again. Okay, I'm starting to see it. So now that we have 100 and went into the 4 times, that's 88. And that leaves us 12. We're going to bring down another 0, and that's going to be 120. Yep, it's repeating. So that's going to be 5. So look at what's happening. It's repeating which part? The 5 and the 4. So I could have rewritten this number as 1.954 and put a little straight line on top of the 54 to communicate to the person looking at this that this number keeps going on and on and on forever. 54, 54, 54. So notice we didn't put it over the 9 because the 9 is not the one that's repeating. All right, as we mentioned in our opener, how do we solve this now? Well, we need to make these two look alike. So we can convert this fraction to a decimal, or actually we can convert this decimal to a fraction. So I'm going to do the latter first because we're talking about converting fractions to decimals. I know that part. I'm just going to give you a little bonus and say, what if we converted this 7/8 into a fraction? That would be 6 4/10. Rewriting this as a mixed number, it would be 7/8 plus 6 times 10 is 60, plus 4 is 64/10. I can't add these yet because I have unlike denominators, 8 and 10, but I could get like denominators. But man, this is becoming a lot of work. So I'm glad I did it this way so you can see the value of changing this to a decimal. Because now I have to find the least common multiple of these two. If I break this into 2 times 2 times 2, and this into 2 times 5, and then I'm going to have a 2, and let's put this 5 over here. 2 times 2 times 2 times 5. So that's 2 times 2, that's 8, that's 40. So the least common denominator is going to be 40. So this will end up giving us 40 and a 40 here. So 8 times 5 would give us 40. So 7 times 5 would give us 35. To get this a 40, we need to multiply by 4 on the top and bottom. So 64 times 4, because 10 times 4 gives us 40. So I need to multiply by 4 up here. 64 times 4 is 256. So, wow, look at all this work. My goodness. 256 plus 3, 256 plus 35, 11. Right here, 8, 9, 291. So that's 291 over 40. Wow. Woo. That's a lot of work. So let me show you why it's important to be able to do this now, because we don't want to do all that again. Let's do 7 divided by 8. So let's actually convert it to I'm going to go ahead and erase all this and just start clean. So we do 7 divided by 8, which is what we should have started with. 8 doesn't go in there 0 times, so we're going to put a decimal. It's going to be a 0 here. 8 goes into 70 8 times. 8 times 8 is 64. It's going to be 6. Bring down our 0. 8 goes into 60 7 times, because 8 times 7 is 56. Leaves us a 4. Bring down a 0. 8 goes into 40 5 times, and it's going to give us 0, so we're done. So now I know that this 7 over 8 is the same thing as 0.875. And it makes it easy now for me to add 6.4. So 6.4. And notice that when I add, I was sure to line up my decimals so I get the right answer. So 5 and 0s, 7, 0, 8, 2, 6, and that's 7. So now we get 7.275. Now this is the same answer we got as a mixed number a second ago, but my goodness, look at the work and look how much more quickly we can do it than doing all the other stuff we did when we converted this to a fraction. So let's not do that next time. Let's go straight to a decimal. Did we answer our questions? How do we convert fractions to decimal? Yep, we just divide the two. So if we have 3 over 7, we just divide 3 divided by 7. And whatever you get there is your decimal. What is a repeating decimal, and what notation we use? Repeating decimal is when you have something that keeps repeating, and we use this little notation like a line bar on top of those numbers to illustrate that. Hey guys, as usual, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.